think I can hear you now. Hello?
Hello, yeah, I can hear you.
Oh, okay, now I can hear you. Yep. Cool.
Okay, cool. Thank you. Yeah.
Awesome. um,
How's the day going?
yeah, good, thanks. How's yours?
My day is also good. Thank you for asking.
Cool. Shall we get started or?
Yes, please. Yes, I'm ready.
Yep. Let's see. Are you interviewing me or?
I believe you are interviewing me, if I'm not mistaken. Oh,
Oh,
interviewer, the masked hedgehog. Oh, I am the interviewer, I guess.
yep. Yeah, I think so.
Okay, okay, cool, cool. I'm so sorry. I thought, never mind. It's okay. I
That's
hope
all
it's
right.
okay with you.
What was that? Sorry?
Okay. Oh, I
Yep,
was
yeah,
saying,
no
I
worries.
hope it is okay, cool. Okay, cool.
Yep.
So, let me introduce myself, first of all, and I'll do a quick introduction so that you have enough time to solve the problem. And don't worry, I'm not
Yeah,
gonna
sure.
rush through
Yep,
or, you know. So,
yep.
I have been in industry for about 14 years. Uh, I'm at a senior level, worked at a couple of big companies, then a couple of startups. Um, I think coding interviews are challenging, and I have been on both sides. I have interviewed myself several times and failed several times.
Right.
So,
Okay. That's fair
and
enough.
yeah,
Yeah.
and there are a lot of technicalities. Like I understand the challenges. Like there are algorithms, and then there are different kinds of problems, and then
Yep.
there's choice of language and choice of concepts, and every interviewer is looking for something different. So
Mm.
I try to make interviews as pleasant as possible. So that's my short and brief introduction. Like it's up to you if you want to speak a few words about yourself. What are you looking for from this experience? I'll be happy to uh, you know answer any of your questions.
Yeah, sure. Yeah, look, I've been doing software for about, just a bit less than a decade.
Okay.
Started, yeah, interviewers are challenging and I've been practicing for a while now, but I never really did any algorithms or data structures at university.
Okay.
So yeah, that's why it was a bit of a challenge. But yeah, look, I've been practicing and trying to get into probably the FANG companies. And yeah, look, I failed a few times. Still trying and getting more experience and learnings along the way. So I think I just probably need strategies on how I can solve the problems. But yeah, I mean I know I need to practice and I have been practicing. That sometimes there's a bit of luck that that comes into it. So, but yeah,
Yeah.
hence that's what I'm doing.
Cool. Cool. Fair enough.
Yeah,
Well said. There is definitely luck involved. So without further delay, what
yeah,
I'll do is I'll ask you to pick a programming language of your choice. It's totally up to
sure.
you, whichever one you want to pick.
Yep, I'll just choose Python. Sorry. Yep,
Perfect. Yeah, that
yep,
sounds great. And I'll adjust the screen a little bit. Okay, so what I'll do is I'll delete this text. I believe you're familiar with the coding environment already.
yeah, yep, sure am. Yep.
Okay, cool, cool. So here is a simple problem, and since you said
Mhm.
algorithms, data structures are sort of challenging for you, I thought I'll give you a simple data structure problem.
Okay,
It's
sure.
it's
Yep.
okay. So think about it like this: we have
Mhm.
linked list. So we have this is a linked list. I'm drawing a linked list or trying to draw a linked list. So this is one, three,
Yep.
four.
Sure.
7, oops, and this is 1 linked list. Now imagine there is another linked list, and the way I would represent that, well, I can type a up arrow. Imagine this is my linked list, a second linked list. So my first linked list is
Yeah.
1, 3, 4, 7, 9, and it terminates here. Like 9 terminates. There's nothing here. I don't know how to put it,
Yep.
but I'll say this is termination. It's terminating there. And then there is
Sure.
another linked list, which is 100, 4, 7, 9, right? And let me add another
100.
node here, just so that you know. So there are 2 linked lists here. One starts at 7, then goes to 1, then goes to 3, then 4, and then 7 and 9, and then another starts at 100, and it goes to 4, 7, and 9, right? So there are 2 linked lists. The length of one linked list is. Can you tell me the length of the 2 linked lists here?
Okay, so this one is 1, 2, 3, 4, 5, 6. This is the top one is 6. The second one would be 3. Am I right? Or is it 4? Because it's 100 then
4.
points
It's
to
4.
4, or
Yeah,
it's
100
4.
points
Okay,
to
so
4.
it's 4.
Sorry.
So it's 100.
There was no good way for me to represent like I don't know how to draw. Oh, maybe I can do this. Yeah. So this is 100,
Yep.
479, right? Yeah.
Yep. 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 You there? Hello?
Can you hear me?
Oh, now I can. Yep. Hello?
So, yeah, can you hear me?
Oh, yeah. Sorry, you keep cutting out, I think.
Okay, yeah, it's better now? Good? Everything good?
Yeah, that's right. Much better now, yeah.
Okay. So, there are 2 linked lists in memory, and they occupy memory positions, and then there is an intersection. So 4 is the intersection of the 2 linked lists that I've drawn. So first
Right.
linked list is at contains memory locations contains 713, 479. The second one has 100, 479. And as you can
Yep.
see, 4, 7, and 9 memory locations are common to the 2 lists. Correct?
Yes, that's correct. Yep.
Right? And then the intersection point, I'm trying to define terminology here so that it's easy for us to talk. 4 is the intersection point of the 2 lists. Right? It's an intersection because that's the first node which is common to both the lists.
Yep.
Right? Make sense?
Yep.
Okay. Now what your goal is essentially to implement the function, and I'm going to write a function prototype. Find intersection.
Right.
And you will be given linked list 1 and linked list 2. Linked list 1 and linked list 2 are basically head pointers. So you get a 7 for you get a like a L1 contains reference to 7 and L2 contains reference to 100. Now what you have to do is you have to find the intersection. You have to tell me what is the so you can return to me the node where the 2 lists intersect. So you have to return the node 100, node 4, right? And it might be the 2 lists don't intersect at all. So for example, I can give you another scenario where you have, let's say, just like this. You have 100 and you can have something like this where you can see that this 7, it's not 7, let's say it is 6, and this is I don't know 34. So these are the other two lists which don't intersect. Even though there is a node 4 common, the value is common, but they don't intersect at all because there is no common memory location, right? And the class node, the definition is given to you. Class node inherits from object, and what it has is df init self value, and it is what self dot or not value, let's say data self dot data equal to data, and self dot next equal to none, right? So this is given to you. Class node is given to you. You have to implement this function, right? Implement to be done.
Right.
So that's what you have to do.
That's okay. Yep.
Essentially.
Okay. Yeah. Okay. So the only time that's actually intersect is if it's actually equal in memory. If it's not equal in memory, it's not an intersection. Is that correct?
Yeah. And equal in memory. What do you mean? If the memory address is the same.
Yes. Sorry.
Right?
Yes. The memory address is the same. Yes.
Exactly.
Okay.
Correct.
Okay. And let me see. What did you want me to return? The actual node itself. So does it the actual intersecting node, and then it could be like 4 in this case here. So I'll just return that one, right? And then that would just link to 7, or it doesn't really matter which one. Oh yeah, because once it intersects in memory, it should actually be the tail. The next node should be actually equal as well. Yep. So for example, 4, when I return it, that should actually be returned to 4, 7, and 9. Like so, right?
Yeah, right. So it doesn't matter. It doesn't matter because if you give me 4, then I'm only concerned with 4, and the job of your function is done. As soon as you return me the 4, I'm good. And the client, let's say the client code, can use that reference to node 4 and maybe print it or maybe do something else with it. That is not your a consideration, if I can say that. All you have to do is just tell them, hey, this is the node where the intersection happens, and I'm returning you that node. Now you can do whatever you want with it. And then if they don't intersect, you just return a none. You return a none, right? Yeah.
Okay.
So you don't have to get confused with the fact that if you return a 4, then you're returning 7, 9, or none. None is basically the ending thing. Yeah. But I just wanted to help you there. That's all.
Yeah, that's okay. 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 I guess the first thing I was thinking of actually was to iterate through the first list and second list, and build up. You see, I can solve this using if it's an array. So if I'm building this into an array, the problem with this is that I don't know if it's actually exactly in memory, if they are actually in the same memory allocation. So for example, if I build this one here, I mean, that's my initial thought first. Then I can actually find the intersection by just using pointers like so, by incrementing this one. Are they in order or anything like that? They're not in order, are they?
They're not sorted. No, they're not.
Yeah, they're not sorted, so that's not going to help me either. Even if I built that, how do I know for a fact they're actually intersecting?
Yeah, so I'll give you. That's a fair consideration. I think.
Yeah.
And I can tell you that without giving away the answer. So in Python, in
Mm.
Python, let's say if you have L1, right?
Yep.
You have
Mm.
4 lists, this one, and you have
Mm.
L2, which is 7, 8, 9, and 10,
Yep.
right? This is
Mm.
L1 equal. So L1 equal to L2. What do you think it should give me?
False.
False. Correct.
Yep.
Why does it give false? It gives false because if you do ID is the way to get the address. So this is the ID of L1 and this is the ID of this. These two IDs are different, right? The list
Mm.
equality basically. So even if you had like, let's say, L1 is this, right? You did L2 equal to this. Even then, L1 equal to L2. Okay, so now it is true. And the reason it is true is because I think the IDs, either the IDs are the same, no, the IDs are different. So the list equality basically is implemented by the contents. That's how the
Yep.
list equality is defined. But for nodes, for our node class, we don't have the default, like we don't, the way we have implemented equality, just think about it, is that the IDs should be same. We are worried about the IDs.
Mm.
The ID that I was referring here, this ID1, IDL1, and
Yep.
IDL2, they should be the same,
Mm.
right?
Right. Yep.
So so that's how. So let's say if you have N1 equal to node 3, it non-type object is not callable. What happened?
I think you meant to call none, node, not none. Yep.
Oh yeah, sorry. Node,
Yep.
right? Node not defined.
You have to define the
Just
node.
okay. Now I think N1
Good.
equal to node 3 this,
Yep.
and N2 equal to node 4. So you see
Mm.
N1 and N2,
Mm.
N1 equal to N2. This will be
It's
false
false. Yeah.
because
Mhm.
and you will, if you do ID of N1 will be different from ID of N2. Sorry, like this. So they are
Yep.
different.
Mhm.
But
Mhm.
yeah, but in case of list, they have overridden the equality operator to disregard ID. But we are going to consider ID. So that's our default. That's our like implementation for Node that
You're
the
right.
data even if they have the same data, it doesn't matter. They have to have the same address. So so that's so
Yep.
you have
So
to yeah, right.
yep.
So
And
this is how you
one
will
is
find.
yep.
Yeah, this is how you will
Mhm.
find if they are the same node. You just compare the IDs of the two nodes, or you can also say N1 equal to N2.
I see.
Yeah.
I see. Okay. Um, I guess that's one thing we could do is actually just go through the link list for list one
Okay.
and filled in the IDs in an array. I mean, that's
Okay.
probably thinking brute force first. So you basically have ID. Thanks for that tip.
Okay.
That's helpful.
Sure.
So it could be ID, I don't know, 2, ID 3. This would be for linked list 1.
Sure. Sure.
And
Uh huh.
linked list 2 would be the same here. And then it will have its own IDs here.
Okay.
I don't know, I'm just spitballing here. These are the different numbers. And
Sure.
if to find the intersection, if there is one, there is a Python, a simple way of doing it, basically, is to see whether it's not the intersection of those IDs.
Right. Right.
And then I should get an intersection here, and that would
Yep.
be an array, I think, that I get from memory. So, for example, that would be like that, and I'll have an array here.
Mhm.
Then the thing is, I have the ID, but I don't have the actual node, so I need to just.
Yeah.
I think I just return the first one. I believe is all I need to do, and that is the ID. Although, okay, the other option is as I build this up, I'm consuming more memory, but the ID can reference like being a hash map, and that's the actual node, for example.
Mm-hmm.
What I was actually thinking. So then, when I actually find the answer, the intersection of it, I could just return. Let's say this is the dictionary.
Yep. Yep.
Then I can just return the actual, for example, the dictionary of the first result, I believe, is all I need. If there is one, if the length of the result is more than 0, otherwise I just return none, right?
Right. Right.
Yeah, because there is no intersection there. That's what I was thinking. Does that sound
So
reasonable to you?
let's think about it for a second. Look at it closely.
Mm.
So your approach is
Mm-hmm.
iterate over the list, create a hash map of ID to node. Correct? That's for
Yes,
linked list one,
correct.
and do the same for linked list two. So now you have two dictionaries
Correct.
that are mapping of
Mm-hmm.
IDs to node. Correct? Now you are saying, so remember, dictionaries are unordered collections. There is no order, right?
Mm-hmm.
So you will not be able
Mm-hmm.
to capture, unless you do something special, you will not be able to capture um, which node came first, right? Which is like the intersection node.
Mm-hmm.
Like you have to capture the ID of 4 basically, right? You are interested in node 4. But if you do this, so you will have 713,479, and you will have 100,479. And then if you do an intersection, to do an intersection in dictionaries, like, so let's say we had lists here, right? We had lists. Okay, anyways,
Mm-hmm.
lists are gone. Um,
Yeah.
so you cannot use intersection operator on a dictionary. I don't think so. You can only use it on a set.
Oh, yes,
You
yes.
see what I mean? Right?
Oh, sorry. When I
So
said,
if
when I initially, go on. Yep. I was actually going to build like a list first, but the dictionary just to know what the ID to node is. That's actually all I'm doing. But yeah, but I could build this as a set. So I'll just iterate, like basically these are two sets. Sorry. Yep.
mhm,
And then these are the IDs. And then I do an
mhm.
intersection there. And then this one is, I only have actually one dictionary. That's all I actually need.
Okay.
One dictionary to reference the ID and the nodes. So yeah,
Mhm.
that's, it should be ID here, and then ID four here, and then there's a node 4, something like that. And then hence,
Sure.
um, yeah, once I get the result, I need to get the first one. It should be ordered when it's set. Otherwise,
Sets sets are
yeah,
also not ordered actually. Sets are also not
yeah,
ordered.
okay. Yep. It isn't ordered. I know there's an ordered dictionary, but I'm not sure that's going to help me to be able to use the intersection way of doing it. I mean, the other way I could
Well,
do it is, sorry, go on.
no, no. So
Hello?
what I
Yep.
was, sorry to interrupt you. All I was saying is
Yeah.
that I
Yep.
think I think you need two dictionaries, right? How would you only need one dictionary if you went with this approach?
Um,
You need one dictionary to keep a mapping for linked list one, another dictionary to keep mapping for dictionary two, right? And then you find an intersection, and then you take the first match. Basically, you take the first match, and and then you go to either dictionary and you reference it and you get the node. That was your algorithm, right?
I wasn't thinking of using two because the IDs should all be hypothetically different unless they're intersecting. So if they're intersecting, it doesn't matter. But
Right,
just
but
using
then
one dictionary would be sufficient. That's what I thought, but
no,
mm,
but then let's say they are intersecting, and you got the
Mm-hmm.
all the IDs in a hash map like a dictionary, then
Mm-hmm.
how will you get the uh, node that is the intersection of the two lists?
That would be just through the ID.
No, but how will you know that is the ID? That is the ID of the node that where the two lists are intersecting. Like, how will you identify that ID?
It should actually be in the dictionary because I'm building it all up. If because what matters is the fact that I'm building two lists,
Mm.
and I have IDs. The node is the same, so reference to the same node, ID4. So that's why we only need really one. So I still can find it because this line 38 is what gives me the ID if it's intersecting. So if it's not there, then it wouldn't be in the dictionary.
So you're saying you create one dictionary and then you
Mm.
iterate over the second list and see if one of the IDs appears in the list in the dictionary, right? That's how you're going to do it.
No, I was just going to use, well, I'm just doing the intersect here between the two. The other
Between what?
option between L1
Between
and
what?
L2. So let's
What is
say
L1?
list
What is L1?
one. This is list one. Let's call that
List
list
or
one.
set? List or set?
Okay, let's go this set. Let's go set two. Let's
Yeah,
call this set. Let's
set.
call it
Yes,
set.
yes,
This
set.
just makes it easier. Yeah, sorry.
Yeah.
Set one and set two.
Uh-huh.
If I intersect that, that should give the result. I should get a list of IDs.
You'll get a
If
set. You'll get a set.
a
You'll not
set,
get a.
sorry, a set. Yeah, a set. A set of IDs that I need, and then all I need to do is just get the first
Can I
one.
stop you here?
Yep,
Can I
sure.
stop you here?
Yep.
So how do you create set one? How do you create set one?
Yep. So I'll go through the list, the linked list.
Okay, and you create set one, and
Yes,
then you
that's
go through
correct.
set two,
Yep.
and you create set two,
Yes,
right?
correct. Yeah.
Okay. Okay,
Yeah.
okay, I see what you're saying. So you
Yeah.
create a dictionary that is a mapping of everything,
Yeah.
and then you create set one that only contains IDs, you create set two that only contains IDs, you find the
Yeah.
intersection, and then you go to the dictionary and find a node.
Yes, that's correct. Yeah.
Right. Okay. But
Yep.
but
Mm.
um one care you have to
Mm.
ensure while you're creating a dictionary is that well, it doesn't matter whether it's a mm, okay.
Mm-hmm.
So you do realize that when you do an intersection, right, you
Mm-hmm.
will get four. In this case, you'll get four items in your intersection. Sorry,
That's
three
right.
items: 4, 7, and 9. Correct?
Mm. Yep. That's right.
You'll get IDs of 4, 7, and 9. Correct? Now you are doing an intersection. You are getting 4, 7, and 9. But this is going to be unordered. You will not you will not necessarily get it in order 4, 7, and 9. You could get it like this: 9, 4, and 7, right? Because sets are unordered. So let me write it down. Sets
Yep.
are unordered, right? So you
Yeah.
get it like this. How will you know that 4 is the node? 4 is the ID. ID 4 is the ID that is the ID of the node, which is the intersection.
I guess there's several ways I could do this. Firstly,
Mm-hmm.
mm, um, without actually iterating through the set. Okay, like if I get this list, what I could do is I just go through my linked list, the first one, for example. If there is something in the list to maintain that ordering, this is going to be another extra iteration, but I can just go through, like say the first node, second node, third node, and then it's only when I reach the third node, it's in the ID is in the actual set, then that's how I know that's the first one.
Okay, so basically what you're saying is you create a mapping, right? And then you create all the sets for IDs, you do an intersection, and then you iterate over your first list or
Yep.
second list, and
Yep.
then the ID of the first node that appears in the set, that is your intersection node ID, and you go to the dictionary
Yep.
and get the node and send it back.
That's exactly right. Yeah. I mean, I know it's a long,
Okay.
not the most most efficient way, but that's probably one way I could think
Yeah.
of. Yep.
Yeah. So here, let's think about the time complexity for your algorithm, before you start writing code. So you will create a dictionary. So let's say, so your one list contains, so let's say L1 has n elements, right?
Yeah.
And L2 has m elements, right? Now you create a dictionary so that you have to iterate, right? So this is
Yep.
big O of n, let's say, right?
Yep.
That's big O of
Yep.
n. Now you have to create a set, so that is again big O of n. Agreed?
Yep. That's right. Yep.
And the second one would be big O of m, right? So let's say we call this or, correct?
Yep.
And
That's
then
correct.
you do an intersection. Let's say intersection of the sets, probably implemented in, I don't know, I
That's
guess this
probably,
is implemented.
I
So
think,
also
the
OM
minimum.
or yeah, the
Probably the
minimum
minimum
of those.
of NMM. Yeah.
Yeah. So or, right?
Yep.
Now you got your intersection, and then you iterate over that list, one of the lists, and then the first one which is in the ID. So for every item you do a search. So that would be, I guess, we'll call the search within a set as constant time, let's say. The
Yeah, that's
search in a
right.
set is
Yep.
constant time.
Average
But
case. Yeah.
again, yeah, but you do it like this. So it's OM or OM, ON or
Yep.
OM, because you have to, right, search
Yep.
every item in one of the lists. Okay.
That
So
would,
then, what's your cost? ON plus ON plus OM plus this. So it's a multiple, right? You see, it's a
yeah.
multiple of so
End
it's
calls.
like yeah. So it's over C into big O of n. That is your cost, right? So
Yep.
which is same as big O of n. Correct?
Yep. Yep. That's
That is
right.
your
Yep.
runtime. That is your runtime. Memory complexity. So
Yeah.
coming to
That's right.
memory, you need to maintain a dictionary, so that is O of n, right? Then you have to create a set, so that's multiplied by 2. You have to create second set that multiplied by 3, and perhaps the intersection, you need to store the intersection. So it's like 3 intersection, so it's like 4 times. You have to store your intersection also, right? So 4 times O of n. So that's your memory complexity, right? Agreed? More or less. That's your
Yeah,
memory
more or less. Yeah.
complexity.
Yeah.
Okay. Um, the
Looking at the
solution
way.
I am looking for, yeah, the solution I'm looking for is,
Mm.
um,
Okay.
yeah, your so first
Mm.
iteration, second iteration, and then um, let's call it third iteration. So memory is
Mm-hmm.
O of one, constant memory, no extra
Okay.
memory.
Yep.
Runtime,
That's what you're looking for. Yep.
yeah, and runtime is O of n. So it's like three times, three times O of n.
Right.
So you can do
Right. Sure.
three iterations. So
Mm-hmm.
that is the
That's
expected
what you're looking
solution.
for. Yep.
Yeah, right?
Okay.
Yeah,
Okay.
that is expected solution I'm looking for.
Okay. Let me think. Okay. Let's go back down here.
Hmm.
So the what that's telling me is I could have create a list, and let's say list one, and actually say let's say seven, um, seven, and the actual ID here, ID
Hmm.
seven perhaps, and then it's the same. When I say seven, I'm talking about the node seven,
Hmm.
so I have reference to it, and then I'll do the same all the way through. And well, I need to just do that, and that would be, let's say, 4, and then ID 4, and then this would be just like a tuple. What I actually need
Right.
a tuple of list, and then this is all the way to 9, and then I'll have another list here, which is list 2, and that starts at 100, and that would
Mm.
be, say, 100 DID, and this would be, yeah, all the way to like so. So what I could do is use pointers. Let's say we start from this one. They both, let's say this one, let me call this I, and let me call this one J. So what I could do is just iterate through each one, so compare them. If they're both not equal, then how do I know? Do I iterate the first one or do I iterate the second one? Don't know
Can
that.
can I
Yeah, sorry, go on.
can I interrupt you?
Yeah,
So
sure.
if
Yeah,
you
sure.
create two lists like this, then
Mm.
you are already using extra memory, right? Like, but the requirement is that you don't have to use any extra memory. You see what I mean?
Oh, yeah, sure. Yep, I see what you
So
mean.
yeah, you can't create
Okay,
extra. Yeah,
okay. So instead of creating it, I need to loop through the linked list and
exactly.
compare them. I guess it's the same thinking, but I'm just looping through using linked list. So I'm just wondering how I do that anyway. When I loop, I use .next. Yeah, yeah. While
So,
while it's still
so
available. Let me just
right.
go on.
So think about it like this. So first of all, we need to
Mm-hmm.
come up with a like
Mm.
look at the list 713 479
Yep.
and 100 479. How what is one possible way that we iterate over the list, right? Iterate over this thing, and we jump on and we arrive at 4 at the same time. So you have one pointer that is iterating over list 1, another pointer iterating over list 2, right?
Yep.
You
Mm-hmm.
see what I mean? So you are at your pointer 1
Yep.
is at 7, then 1, then 3, pointer 2 is at 100, then 4, then 7, right? and then your pointer 2 is at 9, your pointer 1 is at 4. So when you run out of pointer 2, what if you started iterating over list 1? So what will happen is, think about it like this. So this is P1. Think of a way. So P1 is at 7 and P2 is at 100, right? Then you are at 1,
Yeah.
P1 is at 1, P2 is at
Yeah.
4. Agree? Then you are at
Yeah.
3, this is at 7. Then you are at 4 and you are at 9. And then after P2 is at 9, you're done, right? P2 is done. But what if you switched, so this will go to 7, P1 is still alive, it goes to 7. But from 9, it goes to 7. Like it goes to 7, right? And then, like, okay, let's call it 17 so that you get the idea without getting confused. So 17, 134, 17, 134, 100, 479. Then P1 goes to 7, P2 goes to 17, right? Then this goes to 9,
Okay.
and then this goes to 1.
Mm-hmm.
You see what I'm doing? Essentially, after P2 runs out, it starts iterating over P1, right?
Mm-hmm.
And after
Right.
P1 runs out, it starts iterating over P2. Just formatting it a little bit
Okay.
for extra
Interesting.
readability.
Yeah, no worries.
Yeah, it's a sort of a
Mm.
trick. So
Yeah.
P1 goes to 100, and then P1 will go to, after 100 it'll go to 4, right? And then
Mm.
P2 goes
Mm.
to 1, and then it'll go to 3, and then it will also arrive at 4. So there you go. You got a
It's a
match.
cycle thing, yeah.
It's a cycle thing, right?
Interesting. Yeah.
Versus versus if you had, let's say, um,
Mm.
you had, let's say, 100
Mm.
like this. You had something like this, right? So what will happen is, in this case, now think about what will happen here. And see,
Mm.
you will wonder, until how long do I have to do this, because I can go in an endless loop.
Yeah, that's right.
My P1 ran out, it started with P2, like my P1 ran out, it started with list 2. My P2 ran out, it started with list 1. And then when my P1 runs out again, should I start again? No. All you have to do is iterate of using the 2 pointers on both the lists only once. So now you have P1 and P2 here. So you have what, 17, and then 1, it won't match, then 3 won't match, then 4 won't match, then 7 won't match, then 9 won't match. And then for P2, your 100 won't match, then 4, then 7,
Mm-hmm.
then you have 9, it won't match,
Mm-hmm.
right?
Mm-hmm.
Now after 9, it will go to 17, then
Mm.
it will go to 1, and then from 9 it will go to 100, to 4, to 7, to 9,
Mm-hmm.
and then this 17 will go to 1, 3, 4, 7, and 9.
Mm-hmm.
Makes sense?
Mm-hmm.
But, and this is when you stop, because your P2 is flipping here, right? It
Mm-hmm.
is flipping here. P2 flips,
Right.
and where does your P1 flip? P1 flips here. This is where P1 flips, P1 flips, right? And then after P2 flips and it reaches end, you stop. And after P1 flips and it reaches the end, you stop.
Yep, that makes sense. Yeah.
And you will you just have to do it for length of L1 plus length of L2. That much time only. You see,
Yeah.
how many times
Okay.
you go? 10. There were 10 iterations. 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9,
Yeah.
10. So your loop runs 10 times only, which is equal to the length of L1 plus length of L2, right?
Yep. This
So
reminds me of a
that is
very
one.
similar problem. Yeah, go on.
Yeah, so this is one way to do it. Another way to
Yep.
do it, which is even simpler, which even I did
Right.
not know, and I had to look up the answer.
Yeah,
Yeah,
okay.
I mean, you always learn, right? So
Yeah, that's
what
right.
you have to do is find a length of L1 is linked. So let's say len1 is this, and this is len2, right? So you find the difference between the lengths. What is the difference between the lengths? It is, in this case, it is 2, right?
Right.
The difference is 2. So you take the larger list and you skip the head pointer by the number which is equal to the difference between the two lengths. So in this case, the difference is 2. So you skip the head pointer of the larger one by 2, which means you bring from 17 to 1 and from 1 to 3, right? So plus 2, right? I'm not saying modify the head pointer. I'm saying store your head pointer in a temporary variable and move it forward by 2. And now you start your iteration. So you say 3, your pointer 1 will be at 3, pointer 2 will be at 100, pointer 2 will be at 4, your pointer 1 will be at 4, then 7, and then 7, then 9 and 9. But the IDs won't match, so it will not work out. It will say, no, there's no match found. Look here. So you are at 3, 3 and 100, and then 4 and 4. You are at the same node, right? And then you do the ID. You say, okay, I'm at the same ID, and you return that, right? So this is how this is. Yeah. So this is a
It's still 3N
sort of
though, right?
What is that?
The time complexity for the second one that you showed are still 3N because you still need to get the length of the linked list, right?
Exactly. Yep. I fully agree with you. As I said, the time complexity is it's like 3 into O of n, right? Which is upper bound O of n.
Yeah,
So,
that's right. Okay,
right?
cool.
Yeah. So it's
Yeah, that's interesting. Do you have a link to this problem or that I can do? Or?
let me find a link of this problem for you. And
this reminds me of the problem where you have two strings and you want to see if string 2, for example, is a rotation of the other string 1. So it's very similar.
yeah, exactly. Intersection of two lists, two linked lists. It's you can find this problem if you Google it, you'll find it. It's on LeetCode.
Right.
Yeah, they're on LeetCode. Yeah, you can find it there. It's there.
Okay.
All right.
Sure. No worries. No worries.
Yeah.
Sounds good. Okay.
So I think I wanted to give you some feedback. Go ahead.
Yes. Yeah, that's okay. Give me feedback. Yeah. Sure. Go ahead.
were you going to say something? You were going to ask something?
Oh, just that. Oh, yeah. Didn't get to implement it, but I think this part is more important. The discussion, to be honest, implementation. I'm okay. I can do it. Yeah.
Yeah, yeah. Sorry
Sorry,
about
Tom.
that.
Yep.
So,
That's all right.
so actually, the what feedback I was going to give you is that I think you should
Mm,
you I
mm,
think you were able to come up with an algorithm that is important. You were able to come up with
mhm,
a way of doing things, right? So that's really
mhm,
positive. You got a
mhm,
problem, even though your algorithm was not like the most efficient, but you still
mhm,
were able to formulate a solution in your head. So that's excellent.
mm, mhm,
Now, I think where you need to brush up is your
mm,
fundamentals. Like you were
mm,
thinking that you can take an intersection and then take the first element, but then you can only apply intersection on sets. And then sets are
mm,
unordered, so you cannot really index them. So you have to brush up over there. And then what I would suggest
mhm,
is pick up a textbook, read the theory,
mhm,
and then solve the problems at the back,
mm, mm. Okay.
right?
Yep.
So
Yep.
if
Mhm,
if if you do that, if you do that, that will help you build your muscle around the basics.
mm,
And then once you have solid muscle, your foundation is solid on the basics, then you can build like more complicated concepts on top of that. So I think so
mhm,
that's how I did it. I started off with the basics. I slogged through the basics. I did like a lot of problems on the basics, and once I felt comfortable with the basics, I had internalized the basics. Then I started building more advanced concepts on top of that. So
mm,
that's what you should do. It takes some time, but if once
yeah.
your basics are good, your fundamentals are strong, then I think you will be cruising. But before you
Mm,
can cruise, you have to have your basics solid. So
mm,
that was my
yep.
feedback.
Yeah. Sure. Sounds good. No, I appreciate
Sounds
it.
good.
That was.
Most
I think.
welcome.
I think it's good that you explained. Yeah. The solution and yeah, how to go about it. It's interesting.
Yeah.
Yeah. I appreciate your time for that.
Oh, most welcome. Most welcome. I always try to help interviewees with feedback.
Mm,
Uh,
mm,
I've always done that during live interviews also, like actual interviews, because I think it is important for people who are
mm,
interviewing to go back thinking that, okay, even though I couldn't, you know, even though like, so what they should go back is they should feel that, okay, I learned something from this interview and I have a way forward to improve my skill. That is more important
mm.
than just knowing that, okay, I couldn't do it and I don't know what to do next. It is important to, have
Yeah.
a way forward
Yeah.
that tells them how
Yeah.
they can improve,
Yeah, that's great.
right?
Not everyone's like that though. No, not everyone thinks the way you do. I do appreciate it,
No,
but yeah,
I will
it's
always.
not easy. These algorithms take a long time to get good at.
Oh yeah, yeah.
Yeah.
It will. Yeah, definitely. But I will tell you this: if you
Mm,
start on a path, on a pace that is comfortable for your learning, you will
mm,
eventually things will start falling into place for you. It happens. Once you find your groove, once you find your rhythm in the learning process,
mm,
you will find a way to. It'll happen naturally. You will find a way to start solving more difficult problems and mastering the subject. So everybody's path is different towards
yeah, that's
solving these
right.
kinds of problems. That's how it is.
Mm,
So
mm,
so
mm,
that's, I mean, everybody learns differently. Everybody has a different path. The goal is the same, but the path is different. So don't compare your learning path with somebody else's. Even though you can look at somebody else's
mm,
learning path and maybe take elements that are more suited to your learning style, but everybody's path is
mm.
different. It's everybody learns
That's right.
differently.
Yeah.
Yeah.
exactly. Yeah. Okay, no worries. Yeah, thanks for that. That was very helpful.
Most
And I just got
welcome.
to keep practicing, I guess. Yeah. Okay.
Yeah, study the theory, and then solve the problems. But I think in your case, I think you
Yes.
should brush up on the theory.
Yep. Sure. Okay.
Okay. Anything
Anyway,
else?
yeah. Thank you.
Anything else?
I think that's it. Yeah, I
That's
think
it.
that's it.
Okay.
Yep.
It was okay. Sure. Thank you for your time, and thank you for
Yep.
talking to me today. I really appreciate it, and I wish you all the best. And please have a nice day.
Yep. Thank you. Okay. Bye bye.
Most welcome. Bye bye. Take care. Thanks.